So first off, we're going to look at digital inputs and outputs, which is kind of the bread and butter of basic electronics. Mainly, you push a button, or you turn a light on or off, or you sound a buzzer, or you don't sound a buzzer, or anything like that is digital. So basically what you want to do is just set up the hardware kind of like this. And they tie the cables in knots for some reason, maybe to make it more difficult, but this cable comes all the way around and comes over to the LED. And the cable plugged in way over here actually goes back and forth and comes out to the button over here. So basically, it explains where you want to plug them in and their labels. So on the brick itself, you know how I was talking about like the digital number values and the analog ones? On this brick, it just says D8, D9, D10, D11, whatever. That's the digital inputs and outputs. And then along the other side here, it says A1, A2, A3. Those are all the analog ones. So stay away from the analog ones until we get into sensors and just hang out on this digital side where it says, they're labeled as like D something. Yeah, and then all you want to do is, so the LEDs are some of the little red boards that are in your kit that look like they have a little clear square with a little bump in the middle. I'm sure you guys are more than familiar with LED lighting and LED stuff on computers and whatnot. These ones look a little bit different than a standard LED, like what Philip has on his board here, where it's just like a, I don't even know how to describe it, like a little mini hat, I guess. But your guys is, and they should say LED on them. They've got a little white translucent square. And then the button should have a big yellow push button on it that gives a really nice haptic feedback when you push that in. So if you've got those, if you put the board on top of your Arduino, because you're not going to need to look at your Arduino anymore, line up all the pins. If you shut it down, you should be good to go. Depending on which ones you have, you might want to put a little bit of like a plastic bag or something, or a piece of paper in between this big metal bit, because some of the Arduinos are made with a bigger USB thing. So if this is touching any of the stuff on the other board, it might short out. If it's not touching, don't worry about it. If it's close, then just slide something in that's not going to conduct, like paper or plastic. And all you want to do is plug the LED into this port, and the button into this other port on the other end. So it's the LED should be connected to D12 and the push button to D8. And then once you've got that, the next page actually has the code that you're going to want to write. And once you've got that code in, type it up, then I will run through it with you guys. So if you're having issues setting the LED or a button or anything like that, toss up your hand, wave at me, and I'll give you a hand. Or one of the young guys, one guy's will give you a hand. So if you do this very, very simple code, put it in, what you should be able to do is anytime you're pushing the button, the light will be on, and you let go, after 100 milliseconds, so a tenth of a second, the light will turn back on. One thing to be careful of, guys, is code is case sensitive. If you use all capitals or all small letters or a mixture, you have to do it that way every time. It might prevent you from burning up. It's good. Well, I mean, you had both dials. It's true. Okay, so it looks like all of you have the push the button and it'll work thing going on. So I'm just going to very quickly explain the different parts of the code in this one because our code is going to get more and more complex as we go. So it's good to have questions answered now as opposed to later. So anytime you have, and I'm assuming all of you have the code either in front of you on paper or on your screens. It's a little hard to see up here, but anytime you have slash asterisk, slash star, anything after that, either on that line or below that line, is going to be a comment. So it'll just get thrown out by the computer. It's literally just for the human that's writing the code. And it won't end the comment until you have a star slash at the end. So these could be, like if you put one of these, took this one out and put it down here, the whole code would be a comment. And anything that's a comment, once you say either run or verify or upload, the computer will actually just take those out before it does anything with the rest of the software. So anything that is a comment, and it should be grayed out on your Arduino environment, the computer doesn't care what's in there at all. It will just completely ignore it. Another type of comment, if you want to just do one line of commenting, is just a double slash. If you do a double slash, then anything after that is a comment, but as soon as you go to the next line, you're writing code. So if you just want to comment something at the end of the line, you do a double slash. If you want to do a big chunk, and this isn't really a good example, but like in the blink example that we did before, there was kind of a slash star and then a whole bunch of description, and then a star slash again. So if you don't want to keep putting double slash, type some stuff, double slash, type more, double slash, type more, this is just a nice clean way of doing a whole chunk of commenting. And then after that, you have the two required functions that you have in any Arduino sketch. You absolutely have to have a void setup. It has to have these round brackets, and whatever you want to put in that function has to be between curly braces. So you have to have your void setup, it has to have round brackets with nothing in them, and then you have to have your curly braces and some more curly braces. It doesn't matter where the curly braces are, you can put all of this on one line because the code is just going to eliminate and throw out any white space. So if you hit enter 100 times between here and here, it'll just throw it out. If you hit space 10 times or tab 10 times or whatever, it'll throw it out. So when you're writing code, make sure you write your code so that you understand what's going on. Right? So if you start a curly brace on one level, generally I like to finish the curly brace on the same level, and then anything inside is tabbed in. So you know, okay, all of this is part of this kind of enclosed space, and that enclosed space is defining what this means. So it's basically saying the void setup, this function, anytime something calls setup, do everything that's within these curly braces, basically. And then similarly for the loop, void loop, again, nothing in round brackets. and then curly braces holding everything that happens to that function. Those two functions have to exist in only one copy. You can't have like 3 setups or whatever. You can only have and must have one setup and one loop. Right? And then basically all it's doing here is telling the board that it wants pin 12 to be an output and pin 8 to be an input, right? Which is exactly what it says over here, right? The big thing to remember is that setup runs once when the board turns on or when it restarts. Loop runs continuously over and over and over and over and over. So if you have something that you only want to happen once, or only when the board starts up, you put it in your setup. If you want it to happen over and over and over, then you put it in your loop. That's pretty much how all sketches work. Even when there's pages and pages and pages of code written that does all kinds of different stuff, then you have using the entire board and all kinds of stuff like that, you always have your setup, which runs once, and your loop, which goes over and over, no matter what. And then basically all it's doing here is it's introduced an if statement. So it's saying if whatever's in these brackets is true, then do whatever's in my curly brackets. Right? So the loop function has this set of curly brackets that says do this every time. And then the if says if this is the case, do what's in my curly brackets. So effectively, it's saying digital read 8. So it's reading pin 8 and looking for a true or false. A yes or no, a high or low, 1 or 0, however you want to think about it. And it's checking if it's high, which is 1 or true or whatever. High and low is basically just what they use. Because once you get into the electronics, it makes sense to think of it in terms of actual voltages on the board. But high and 1 and true are all the same thing. And low and false and 0 are also all the same thing. All right? So basically what it's just saying is it's reading in 8, which is where you should have plugged in your button, and it's checking if it's high. And those buttons are configured so that if you push them, they're high, and if they're not pushed, then they're low. So if it's high, it's writing a high to 12. So it's saying, hey, pin 12, go high, or hey, pin 12, turn on. And pin 12 is what you hooked up your LED to. So basically this line just says turn the LED, just like it says over here. And it's always good when you're writing code to leave comments, either for yourself or for someone else who's going to read it. Because anyone can come in here and just look over here and be like, okay, well, it sets it as an input, it sets this as an input. If the button's pressed, it turns on the LED, and then it turns off. The reason that when you're holding it on, it kind of looks like it's strobing a little bit, is because if it's high, it turns on the LED, and then it waits 100 milliseconds, and then it turns it off, right? It sets 12 to low. But then the loop immediately jumps back to the beginning, checks if the button's pressed, and turns the LED back on. So while you're holding it, it's going to, like if you're holding the button in, it's going to get in here. It'll say, yes, it's been, the button is being pressed, turns the LED on, waits a little bit, turns the LED off, and then immediately checks again and turns the LED back on. So basically what it's saying is 100 out of 102 milliseconds have the LED on if the button is being pressed. So you might see a little bit of a flicker in there every once in a while, but effectively, you push the button, the light's on, you let go of the button, the light turns on. What questions do you have about that?
Is there a particular reason why you have to keep the delay? Like, can you take the delay out and you just have to specific reason for that?
Yes. So the thing is, when the button's pressed right now, it executes everything within the curly braces. But whether or not the button is pressed, it always does this second one, right? Because that one isn't in curly braces. So if this delay wasn't here, if you haven't pressed the button, it'll skip everything within these curly braces, and it'll just turn it off over and over and over. But if you're holding the button, all it'll do is turn it on, and then there's no delay, so it immediately turns it back on. So, and then it'll come back, and it'll think it'll ask this question. And anytime it has to do anything, you can basically think about each line as taking a little minuscule amount of time. But brackets don't take any time. So basically it's turning it on, turning it off, question, turning it on, turning it off, question. So it's going to be off, and then still off when you're asking the question, and then turn on and turn right back off. So you're never going to see it go on. That's what the delay is of this one. Yeah. And if you wanted to, you can set this delay to like 2,000 for 2 seconds. And then as soon as you push the button, it'll turn on. And then when you release the button, the LED will stay on for 2 seconds after whenever the last time was it checked if the button was pressed, basically. And then it would turn it off. So it's a nice way of doing like delayed things, or maybe you want to say like if the button's been pressed, wait 2 seconds and then turn the light on. So someone can come by and push the button and be like, oh, I didn't do anything, and turn around, and then you could like flash an LED or something.
How would you set it up so the light would stay on and then press it again and turn it off?
That's the two.